3 different types of magnets. Magnets are materials that generate a field that attracts or repels certain other metals from a specific distance. This invisible field, known as a magnetic field, is responsible for the fundamental properties of a magnet. Ancient people have been using magnets since at least 500 BC, and the earliest known descriptions of such materials and their characteristics come from China, India, and Greece around 25 centuries ago. Artificial magnets, however, have been created as recently as the 1980s. Obviously, not all magnets are composed of the same substances, and thus can be categorized into different classes based on their composition and source of magnetism. Below is the detailed list of 3 major types of magnets, along with their properties, strength, and industrial and non-industrial applications. Number 1. Permanent magnets. Once magnetized, permanent magnets can retain their magnetism for an extended amount of time. They are made of materials that can be magnetized and produce their own persistent magnetic field. Usually, permanent magnets are made of 4 different types of materials. First, ferrite magnets. Ferrite magnets are electrically insulating. They are dark gray in color and look like a pencil lead. Ferrites are usually ferromagnetic ceramic compounds made by mixing large proportions of iron oxide with metallic elements, such as manganese, barium, zinc, and nickel. Some ferrites adopt crystal structure, like strontium and barium ferrites. They are quite popular due to their nature. They are corrosion-free and thus used to extend the life cycles of numerous products. Ferrite magnets can be used in extremely hot conditions. The manufacturing cost of such magnets is also low, particularly if they are produced in high volumes. They can be further subdivided into hard, semi-hard, or soft ferrites, depending on their magnetic properties. Since hard ferrites are difficult to demagnetize, they have high coercivity. They are used to make magnets for applications such as small electric motors and loudspeakers. Soft ferrites, on the other hand, have low coercivity and are used to make electronic conductors, transformers, and various microwave components. Second, Alnico Magnets. Alnico magnets are composed of aluminum, nickel and cobalt, hence the name Alnico. They often include titanium and copper. Unlike ceramic magnets, they are electrically conductive and have high melting points. In order to classify them, the Magnetic Material Producers Association has assigned them numbers, such as Alnico 3 or Alnico 7. Alnicos were the strongest type of permanent magnets until the development of rare earth magnets in the 1970s. They are known to generate high magnetic field strength at their poles, as high as 0.15 Tesla, which is 3,000 times stronger than the Earth's magnetic field. Alnico alloys can retain their magnetic properties in high working temperatures, up to 800 degrees Celsius. In fact, they are the only magnets that have magnetism when heated red hot. These magnets are extensively used in consumer and industrial applications. A few examples are magnetron tubes, sensors, microphones, electric motors, guitar pickups, loudspeakers, electron tubes, radar, and traveling wave tubes. Third, rare earth magnets. As the name suggests, rare earth magnets are made from alloys of rare earth elements. They are the strongest type of permanent magnets developed in the 1970s. Their magnetic field can easily exceed 1 Tesla. The 2 types of rare earth magnets are samarium cobalt and neodymium magnets. Both are vulnerable to corrosion and highly brittle. Thus, they are coated by a certain layer to protect them from chipping or breaking. Samarium cobalt magnets are composed of praseodymium, cerium, gadolinium, iron, copper, and zirconium. They can retain their magnetic properties at high temperatures and are highly resistant to oxidation. Due to their lower magnetic field strength and high production cost, they are less used than the other rare earth magnet. They are currently used in a benchtop nuclear magnetic resonance spectrometer, high-end electric motors, turbo machinery, and numerous applications where performance must be consistent with temperature change. Neodymium magnets, on the other hand, are the most affordable and strongest type of rare earth magnet. They are a tetragonal crystalline structure made from alloys of neodymium, boron, and iron. Due to their smaller size and lighter weight, they have replaced ferrite and Alnico magnets in numerous applications in modern technology. For example, neodymium magnets are now used in head actuator for computer hard disks, electric motors for cordless tools, mechanical e-cigarette firing switches, and mobile phone speakers. Fourth, single molecule magnets. By the end of the 20th century, scientists learned that some molecules could exhibit magnetic properties at very low temperatures. In theory, they are capable of storing information at a magnetic domain level and providing a much denser storage medium than traditional magnets. Single-molecule magnets are composed of manganese, nickel, iron, vanadium, and cobalt clusters. Some chain systems, such as single-chain magnets, have been found to retain magnetism for a long period of time at higher temperatures. Researchers are currently studying monolayers of such magnets. One of the early compounds to have been scrutinized as a single-molecule magnet is the dodecanuclear mixed-valent manganese cage. The potential applications of these magnets are vast. These include quantum computing, data storage, information processing, and biomedical applications such as MRI contrast agents. Number 2. Temporary magnets. Some objects can be easily magnetized by even a weak magnetic field. However, when the magnetic field is removed, they lose their magnetism. Temporary magnets vary in composition. They can be any object that acts as a permanent magnet in the presence of a magnetic field. For example, soft magnetic materials like nickel and iron will not attract paper clips after an external magnetic field has been removed. When a permanent magnet is brought near a cluster of steel nails, the nails get attached to each other and then to the permanent magnet. In this case, every nail becomes a temporary magnet, and when the permanent magnet is removed, they are no longer attached to each other. Temporary magnets are primarily used to make temporary electromagnets whose strengths can be varied as per requirements. They are also used to separate material made of metal in a scrap yard and put a new spin on modern technology, from high-speed trains to high-tech space. Number 3. Electromagnet. The electromagnet was invented by British scientist William Sturgeon in 1824. It was then systematically improved and popularized by an American scientist, Joseph Henry, in the early 1830s. Electromagnets are tightly wound coils of wire that function as magnets when an electrical current is passed through. It can also be classified as a temporary magnet because the magnetic field disappears as soon as the current is turned off. The polarity and strength of the magnetic field produced by an electromagnet can be adjusted by changing the direction and magnitude of the current flowing through the wire. This is the main advantage of electromagnets over permanent magnets. To enhance the magnetic field, the coil is usually wrapped around a soft ferromagnetic material's core, such as mild steel. The wire coiled into one or more loops is called a solenoid. These types of magnets are widely used in electrical and electromechanical devices, including hard disks, loudspeakers, hard disks, transformers, electric bells, MRI machines, particle accelerators, and various scientific instruments. Electromagnets are also used in industry to pick up and move heavy objects such as scrap iron and steel. Are you a fiend for technology? Are you constantly curious? Then why not subscribe to Tech Hub? For more clips like this one? And ring the bell for more fascinating content. See you in the next video. Goodbye.